Another useful way how you can find a limit is by plugging in x values into the function that are closer to the x that you want to find the limit of. So here we have the limit of some expression as x approaches 1. So what we can do is plug in x equals to values that are closer and closer to 1. So 0.9, 0.99, 0.999, and the same, 1.1, 1.01, 1.001. We can't plug in x equals 1, as you see, because the bottom of this fraction is x minus 1, and if you plug in x equals 1, you'd have a 1 minus 1, which is 0. You'd have a division by 0. You can't have that. So you would start by doing, let's say, filling out this table, f of 0.9, that would be root 0.9 minus 1 over 0.9 minus 1. Okay, I'll cheat and use my calculator. I'll use Wolfram Alpha, which is a computational intelligence, as you can see, and I'll write some decimal places there. Maybe 3 should be enough. 513. And then I'll do the same with 0.99. I'll use my keyboard instead. And then if I plug in 0.99, Wolfram's doing the math for us. Taking a little longer than expected. There we go. So we have a 0.501. How about 999? What do we have? You can use your own calculator for that if you want. I just find Wolfram usually faster because it doesn't force me to type the whole thing again. So that will be a 0.500. With 3 decimal places, I don't have a lot of variation, so I'll add a 4th. And let's try with x values that are bigger than 1. So let's try with from the right to the left now. So 1.1, let's say. Let's start with that. So let's say 0.488. We make it a 0.1, so that says 0.498. If I add one more 0 for our last input, have a 0.499. So my first observation before I get rid of Wolfram Alpha on the left is note that you have a graph and you have a point in there, a red dot. Before I speak any more about that, let's look at how our table looks like. The closer my x values got to 1, the closer my y values got to 0.5, both from the left and from the right. So this is very, very close to 0.5. This is very, very close to 0.5. Even though f of 1 is undefined, I would say that it is reasonable to assume that the limit as x approaches 1 of root x minus 1 over x minus 1 equals 0.5.